Summer irrigation season is almost here. That means that home and small business owners will soon be applying valuable water resources to the landscape. It's the responsibility of all Texans to ensure that water is used wisely. An audit of the irrigation system has been shown to be the most effective tool for maximizing water use efficiency in the landscape. Here are some earth-kind tips for system operation and management that will help promote water conservation. Irrigation audits consist of three main activities: site inspection, performance testing, and irrigation scheduling. Each activity in itself can result in significant water and cost savings. Together, these activities provide valuable information based on site-specific conditions and irrigation system performance. Over time, even the most efficiently designed irrigation system will begin to break down. In the absence of a regular maintenance program, minor operation and performance problems can continue for months, resulting in excessive water use, reduced efficiency, and decreased plant performance. Sunken sprinkler heads that don't pop up properly, misaligned spray patterns that throw water onto streets, sidewalks, or hardscapes, and broken or missing sprinkler heads resulting from mower damage can result in significant water waste. Many performance problems are often inherent in an irrigation system. A sprinkler system where the heads are spaced too far apart will result in poor water distribution or dry spots in the landscape. In order to compensate for this poor uniformity, the system is often said to operate longer, which in turn overwaters most of the landscape. Insufficient or excessive operating pressure can also lead to water loss through wind drift or poor coverage. Low water pressure is generally caused by insufficient static pressure or high pressure losses through valves, meters, piping, too many heads, or other components on the irrigation system. Visual indications of low water pressure include large water droplets and short sprinkler throw. High water pressure, on the other hand, indicates an absence of a proper pressure regulator device. High pressure is generally characterized by excessive misting of water that easily evaporates or is blown by the wind. Sprinkler application devices, including pop-up spray heads, rotors, microsprays, and bubblers, are designed to operate within specific operating pressures and head spacing. Manufacturers' specification catalogs rate the performance in gallons per minute and precipitation rate in inches per hour. Commonly, the rated performance listed in the catalogs don't accurately represent actual performance. For example, insufficient or excessive operating pressure and improper head spacing will significantly increase or decrease precipitation rate. For irrigation scheduling purposes, the most accurate determination of precipitation rate is achieved by conducting a catch can test. Catch can test measures the amount of water that actually hits the ground at various points within the landscape, and also serves to measure application uniformity. Since irrigation systems commonly use different types of brands of sprinklers, it's important to conduct catch can tests for each individual zone or station of an irrigation system. A general approach to conducting a catch can test begins with turning the irrigation system on one zone at a time to locate and mark sprinkler heads. Next, starting with Zone 1, lay out catch can devices, usually small plastic containers, only on the part of the landscape covered by Zone 1. These catch can devices should be placed in a grid-like pattern throughout the zone to achieve an accurate representation of sprinkler performance. Turn on Zone 1, allowing water to fill the catch cans, and remember to keep track of the number of minutes that the zone is allowed to operate. After a measurable amount of water has been applied, measure the depth of water in each container using a ruler that measures in tenths of an inch. Record these values on a data sheet along with the number of minutes the zone was allowed to operate. You'll need to repeat these steps for each of the remaining zones on the system. Using the data from the catch can tests, the precipitation rate for each individual zone on the irrigation system can now be determined. The equation for calculating precipitation rate is average catch can depth divided by test run time times 60. Once the catch can tests are completed, it's possible to customize irrigation schedules based on precipitation rate site-specific soil conditions, and plant water requirements. Determining when to irrigate should be based on the depth of the plant's root zone and soil type. Together, root depth and soil type define the amount of water that's available for plant use. Root depth also influences irrigation frequency. Shallow-rooted turf grass, for example, will require more frequent irrigations than will a turf grass with a deeper root zone. The first step in determining how long to irrigate is to calculate how much water should be applied at each irrigation event. Plant water requirements vary significantly in urban landscapes due to the variety of plant species, maintenance practices, and microclimates. Water requirements also vary with climate trends and rainfall patterns. Turf grass, which is generally assumed to be the highest water user in the landscape, requires up to 1 inch of water per week during the summer, with less in spring and fall. Due to limited water storage capacity in the plant's root zone, 2 or 3 irrigations per week may be required. Once it's determined how many inches of water are needed at each irrigation, the conversion to zone runtime is simple. Runtime in minutes equals the targeted irrigation depth in inches divided by zone precipitation rate times 60. Landscape water conservation involves numerous earth-kind principles and practices. However, an irrigation system audit is the most effective tool for reducing water consumption and creating a healthy and sustainable environment. For additional information, including a review of the audit calculations, we invite you to visit our website at earthkind.tamu.edu.